in order to be able to work on this pixel star activity, you have to first open the document. That should be on your Earth Science Canvas page. You go to Modules, and then you find the pixel star activity. When you first open up that PDF, it will bring you to this kind of scenario and directions sheet. You can read through this. I'm just going to kind of summarize and then show you a couple examples of how this activity is supposed to work, and then you can kind of take it from there. So basically the idea behind this pixel star activity is to show you what scientists and graphic artists do in order to see things that scientists collect that aren't really visual images from the beginning. So when we talked about telescopes, and specifically optical telescopes, the images that are created by using that tool are pretty obvious and pretty easy to see because they're collecting visual light, which our eyes can process very easily. But when scientists collect other types of electromagnetic radiation, in this case X-rays, but you could also fill in infrared light, ultraviolet, microwave, radio waves, anything that's not visible light, they have to kind of process and convert that into something that our eyes can see and we can understand. So this activity kind of walks you through how that process goes. So they kind of start you off with a little made-up scenario that you were operating this Chandra X-ray Observatory. There was a computer malfunction and it lost some of the data, and now instead of the computer processing all that data, you are going to process some of it so that you can get an idea of the data that it collected. So that brings us to this next set of pages. The one on the left over here is kind of your data table, so to speak, and you can see all the areas where there's data missing. That was a result of the computer malfunction. So what you're going to do is you are going to take the 5 observations that the X-ray Observatory made or collected, and you're going to average those number of photons. So we'll just start right here at the top. You have 39, 40, 40, 42, and 42. So when you add those up, you're going to get a pretty big number. But what you need to do in order to find the average, if you're not familiar with this or you forgot, is take all 5 of those numbers, add them up, and then you are going to divide by 5 in this case because you added 5 numbers up. You take their grand total when added together and divide by 5, and then that number is going to go right here. So let me grab my handy dandy calculator. So we had 39 plus 40 plus, I believe, another 40, and then 2 42s. Okay, so there's our grand total, and then we're going to divide those by 5. 40.6. Okay. So right here, you would write in 40.6. I don't know if I can do that. Oh, I can. All right. So right here, you would type in 40.6, or you could use markup and just write that in. Okay. Now for our purposes, all you really have to do is probably round to the nearest whole number. So 40.6 is actually a little bit closer to 41. So for here, I would just call that 41. Okay. Now that's pretty easy, pretty self-explanatory for kind of the first data set here with the grid coordinate A4. And then for grid coordinate B6, it's basically the same thing, just different numbers. And then you write down that total here, just rounding to the nearest whole number. It gets a little bit weird when you have a data set with missing data, okay? But in actuality, all we have to do is just process a little less data. These missing ones, you do not mark those as 0 because they were likely a higher number, much higher number in this case. So instead, we're just going to pretend they weren't there, and we only took 3 observations in this case of grid coordinate B7. So we have 62, 71, and 63. Clear this out here. 62, 71, 63. And now, after I added those 3 numbers up, I'm going to divide by 3 to get their average. 65.3, we'll just call that 65. And then you would mark that right here. So basically, that's what you do for all these. If you have 1 or 2 or even 3 missing, you just take the numbers that you do actually have, add them together, and then divide by the numbers, however many you added together. So like this one that's missing 3 data sets for D2, you'd add up 41 and 43, and then take that total and divide only by 2 because you only had 2 numbers that you added up. So then what do you do with this information? You are going to take the totals rounded off to the nearest whole number, and you're going to bring these totals right over here. So this one, I remember it was 40.6. We rounded that to 41. So then we'd go find A4. It's a little bit like bingo here. A4. And I'd write the number 41 right here. Okay? And then you can see all of these other grid positions that have openings. You're going to fill those in with the help of the data from these observations. Okay, so you just do your averages, put the number here, round to the nearest whole number, and then that just gets inserted over here into the grid. So after you have all your numbers filled in for all these missing grid spots, then you are going to color code this. Because what we're really going after here is we are trying to take raw numbers, raw data, and turn that into a visual image that we can see, and we can look for patterns. We can look for, making different observations that can tell us a little bit more about this particular place in space. So we're going to convert all these numbers into kind of a visual picture. The way we're going to do that is we first have to have some ranges, and then we're going to assign some colors to that. Okay. So what I would recommend is you either, when you're choosing colors, go from a light color to a darker color. Don't just make it like light gray, slightly darker gray, slightly darker gray, and then black. Because to really see the differences there, there's not enough of a change. So what I would do is probably pick like a couple colors, or you could even use like the Roy G. Biv part of the visible light spectrum, and you could say, okay, I'm going to start here. Maybe I'll start with blue, then I'll go to green, then yellow, then orange, then red, something like that, where there's a continuum, but it's obvious that this color is different than this color. Okay, and then up here you have to have your ranges. So if we look at our overall range, our minimum is 0, so we have to start here at 0. Our maximum, I think that I saw, is something maybe 155. 216, that's pretty high. Maybe 216 is it? I don't see anything higher. So from 0 to 216, so if we go from like 0 to say 50 here and that's going to go with this color. And then we go 51 to 100 here, and then we do 101 to 150, then we do 151 to 200, then we do 200 plus. And then each one of those has a color assigned to it. And all you have to do is, if there's a number that falls within this range, you color it this color. So this one, I remember, was 0 to 50. So all the zeros and ones and twos and eights and 24s and 32s, you would color them all whatever color you selected here. Then you go to the next group and you see the range there, see the color that you picked, and you color all those. So it's just a color by number. And what you're going to end up with when everything is colored in is something that looks sort of, granted this is a very, 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 very low resolution image, because you're doing this by hand, where a computer that was functioning would do this with probably millions and millions and millions of pieces of data and millions, if not more, of pixels. Okay, so this is kind of like the Minecraft 8-bit picture version of a supernova remnant. All right, but at least you get the idea of how we turn raw data, raw numbers, and something that collects that information into something visual that our human eyes can then see and process and hopefully understand a little bit more. Okay, so when it's all said and done, you'll have a little picture here of a supernova remnant.